Hi, my name is Yeshey. I completed my bachelor's in civil engineering in the year 2018 and completed my master's in environmental engineering and management in the year 2020. After my graduation, I was working as a project civil engineer in Bhutan for more than 2 years. Currently, I'm here in Melbourne and I'm working as a building manager. Since I really wanted to gain some local experience and understand more about the Australian standards and codes, I recently completed my traineeship program with NZ Engineers and LearnPedia Australia. In the brick veneer wall, we start off by nominating single timber lintels for the timber part of the wall. If, let's say, 90 by 45 mgp10 does not meet the design requirements, we can try to increase the size of the timber lintel. And if it does not meet the design requirements, then we can use higher grades or use laminated timber options before switching to PFC and plate directly. Also, for the brick part of the wall, we start off by nominating equal angle sections. If the maximum equal angle section, which is 100 by 100 by 12 millimeters, does not meet the design requirements, then we can nominate unequal angle sections as well. If it does not work, only then can we switch to PFC and plate. When designing lintels in a single brick wall, I need to consider design factors such as the mortar thickness, and wall height above the opening. I would initially start off by nominating 90 by 90 by 6 millimeters of equal angle steel sections. If it does not meet the design requirements, I would gradually increase the size of the EA section. If the maximum EA size, which is 100 by 100 by 12 millimeters, is found inadequate, then I can try using unequal steel angle sections. If the maximum US size 150 by 100 by 12 does not meet the design requirements, I can adopt PFC sections. In order to connect the timber floor joist to steel beam, we need to put a timber packer inside the PFC and bolt it to the steel beam using the pre-existing holes in the PFC. Once that is done, we can connect the timber floor joist to the timber packer using Prida joist hangers. In the subfloor system, the floorboard is supported by the floor joist, which is typically 450 to 600 millimeters apart. Then the floor joists are being supported on the bearers, which are 1200 to 1800 millimeters apart from the centers. Then the bearers are being supported on steel or concrete stumps, which are usually 100 millimeters by 100 millimeters in size and are spaced at 1200 to 1800 millimeters from the centers. And ultimately, at the very end, this concrete stumps are resting on the footing. To assess if the footing that we're proposing is undermining the neighboring's existing footing or not, we draw an angle from the base of the footing that we're assessing. Depending on the soil type, if the soil type is clay, we draw an angle of 45 degrees, and if the soil type is sand, we draw an angle of 30 degrees. If the angle hits the bottom of the existing neighboring property's footing, it means that our footing is deep enough to affect the neighboring's footing. So underpinning is required for the existing footing. However, if the angle hits the side of the footing, it means that the angle of repose requirement is satisfied. The simplified format of AS 1720.1 is AS 1684.2 for designing residential timber structures in non-cyclonic areas, and AS 1684.3 for designing residential timber structure in cyclonic areas.